Let's build an ALU, and what we're going to do for this is we're going to assume that we've got two numbers that we're trying to add together, A and B, and they're each composed in 2's complement notation with a set of bits indexed with the i's. And yeah, the most important thing is that they're in 2's complement, otherwise this doesn't work. Okay, and so we've got 4 functions controlled by 2 control bits, k1 and k0. So if I want to get the output b, I want to basically just have b being added with 0. So what we're going to do is keep our b sub I bits the same, and we're going to 0 out our a's and 0 out our first carry in. For a plus 1, I'm going to keep my a sub i's, and I'm going to 0 out my a's because that's what I need. If I want to increment by 1, I'm going to have a 1 here. In 2's complement, if I want to add anything, I want to do a minus 1. As long as it's all 1s, this number is equal to negative 1 in 2's complement. So what I can do is I can have a sub I plus all 1s in my b column, and then plus 0 gives me a minus 1. And then a minus b minus 1. So I know that in 2's complement, if I complement all the bits and then add 1, that is equal to negative b. And so what I get is, what I've got is negative b minus 1. So I can see that b complement is equal to negative b minus 1. So I just need to complement all my b bits, keep my a bits the same, and then we're going to put a carry in of 0 here. And now that I've got this table, the next step is to create some k-maps and design my circuit. So I'll add some k-maps here, and when so what we can do is just translate based on k1, k0. This is going to be the b, this is a plus 1, this is a minus 1, and this is a oh, shoot, I almost always do this. This is a minus 1, this is a minus b minus 1. It's always useful to check that. And so that's the row that corresponds to this. So for a, when I want to do, this is going to be my a sub I star. This is my b sub I star, and this is c0. And so I can see when for the 0, I want this to be all 0s. When it's a plus 1, I want my a sub I to come back out. So my a sub I is this bit, which is the first one, so it's going to be 0, 0, 1, 1. And I'm going to want a sub I for all of these, so 0, 0, 1, 1 for each of these. And then for my b sub i's, I'm going to do the same thing. So here I want my b bit coming out, so that's 0, 1, 1, 0. Then I want all 0s coming out. And then I want all these to be 1s. Oops. I always do this. It goes on the bottom one. This is the a minus 1 row. So that's that one. And then we have the b complement, so it's the opposite of my b bits. And my c0, it's going to be 0, 1, 0, 0. So a sub I star is going to be equal to these two, which is k1 a sub I, or k0 a sub I. B sub I is going to have these two, and then there's one more prime replicant that we don't need. That one's non-essential. And so this is going to be k0 prime b sub I, or k1 b sub I complement. And then c0 is equal to k1 prime k0. And we can build our circuit after that, and we'll be done.